Good afternoon, everyone. I'm thrilled to be here with all of you today. My name is Zui, Director of Infrastructure Center at MPT Smart Cloud, and my colleague is Sang, Team Lead of Infrastructure Service, R&D. And today, I want to share some of our experience and some experience that we already implemented on our production environments. So hope this session can be good for someone. Okay, so. Let's start with MPT Smart Cloud. We are a subsidiary of MPT Corporation, and we take care for develop and provide cloud and AI service. Besides of that, MPT also have other company, MPT Software, MPT Digital, and other company in telecom and education. MPT AI one of main our product, and you can see we have two main products. The first is omni-channel virtual assistant, and this product are serving 12 million calls per month. Besides of that, we also have MPT AI Mentor. That the product are applied for training, for massive training, and the number of participants in 20,000 money active user. And our client are in the banking, finance, and manufacturing system, and you can see that we are providing MPT Cloud not only for internal user, for MPT AI also. And here is some more capability of MPT. We have more than 1,000 AI professionals working in MPT. And we also partner with some R&D team, Mila Landing AI, AI Automatic, and we also partner with NVIDIA. This collection will help us to approach the NVIDIA technology and software and hardware from NVIDIA. And beyond that, we define AI factory not only is AI infrastructure, but also for AI factory include process, people, and AI platform and AI services. All of that called AI factory. And here is our architecture. You can see here we have two main of infrastructure for the serving zero and AI inference workload. We are using normal CPU and zero CPU A10, A30, A100, and 800 with PCIe. And for the Ethernet network, we are using 10 and 25 gigabit per second, and we are providing the cloud server, GPU server, storage, networking, and other platform service, and we run on OpenStack here. For AI training workload, it requires more performance on storage, high performance network, and low latency. And for the distributed training, we are running on bare metal CPU node with NVIDIA 8100 SCM file. And in this infrastructure, we provide three kind of service. Not only for business, but you can see each service here will suitable for each kind of customer. The first one, we provide bare metal GPU server for the team who can manage the physical, who want their infrastructure in private and controlled by themselves. The second kind, we provide Kubernetes and Slurm for distributed workload, and it's run on bare metal GPU node. But in managed service, customer no need to set up Kubernetes or Slurm by themselves. And our team develop the orchestration software for Kubernetes here. And the third, we are developing a kind of serverless for small demand. You can see one bare metal GPU node here. We have 8 CPU per server. So the minimum hardware here is 8 GPU. But this kind of service we can provide one or smaller than one with multi-instance GPU feature. We can divide one GPU to seven for the 7 containers. So a small customer can using our service. And on top of that, we provide AI as service. We also provide model space to store the model, and as a service to serving for training and optimizing. One important thing here, we provide AI model optimization because you can see each model run on different hardware will provide different performance. So we provide optimization for specific hardware, and with some kind of model, we saw that the performance increase maybe 2 to 3 times. And besides that, we still provide partner with NVIDIA AI Enterprise because we also want to make everything by ourselves, but very difficult. And NVIDIA, they provide some solution that we can avoid that. And here is our overview topology of our infrastructure. We divide to 32 nodes. Is one cluster, and you can see each GPU node will have 8 infinite port for GPU direct with 400 gigabits per second, and we have other NIC for storage direct and connect to other service in our ecosystem. So our cluster can work as supercomputing for whole cluster to serve for distributed training. The next part, I want to hand over to Stan, our infrastructure list.
Thank you, Mitri, for overview about MPT Smart Cloud as well the AI factories architecture. So the next slide I will discuss about how we use OpenStack for AI factories. The first I will overview about how GPU work with OpenStack. Right now we have 3 ways for GPU work with OpenStack. The first, it is a pass-through. This is a very simple approach and the variety of use case. So it's basically attack direct for the GPU to the virtual machines, leverage the IOMU technologies. And With OpenStack, we can to attack multiple GPU per one instance, as well you can manage multi GPU model like A10, A30, A100 in one OpenStack cluster very easy. With the BSABAT rule, the virtual machine can have the native performance like the bare metal. With additional the cloud service add-on like networking, like storage, something like this. And the main use case for BSABAT rule is used for training inference with the heavy workload and IO intensive. And some of the GPU model that not support the virtual GPU like RTX and GTX. Next is about the virtual GPU. Some of the NVIDIA model that support virtual GPU using the SIOV technologies. And one thing to note that vGPU need the license for full functionality, and the definition with vGPU is the visual will grab partitions, and but the compute capacity is time shares among vGPU on top of one physical GPU. And the number of vGPU capacity depend on the GPU model. Example, for example, I have V100 right here, and with every number of RAM, GPU RAM, they have the number of GPU capacity can provide to the virtual machines. And the main use case for vGPU is create a virtual machine for the workstation PC, cloud desktop, and cloud gaming. So the next is my testing for vGPU for playing game from 2020. It's a good use case for the virtual GPU. Next is about a multi-instance GPU, MIG. This is the latest technology of NVIDIA, which created to support the containerization and Kubernetes. So it's worked very well in the containers environments. It's different with the vGPU is it's not need the license, and the memory and computational capacity are both statically packed. And right now the KVM is not fully support for MIG for the direct attack to the VMs. So right now we can do but besides through the GPU to the virtual machine, then we can use the MICs in the container level. So this is a high-level service landscape. The first, thanks to Ironics, we can provide a GPU bare metal as a service for the customer. And then with the PCI pass-through, at the attack the virtual machine, we have the GPU cloud server with capacity to support multi-GPU per VM or multi-models in one OpenStack cluster. And also with the vGPU grids, we can to divide one GPU to multiple vGPU, and then we provide the vGPU cloud servers and support for the cloud desktop and the gaming purpose. With the MIG, right here we pass through the GPU to Kubernetes nodes, and then the port can using the driver of NVIDIA to the attack the MIG instance to the container port, and then we provide the Kubernetes service with GPU worker or container service. So, and next I will talking about some of my experiences in optimization and some issues while working GPU with OpenStack. The first is about in hardware number profile. You know, some of bare metal providers use the first one for the number of files with attack on the BCI GPU on one number. So this is not good for the hypervisor and virtualizations, because when the VMs spawning in this number and it connect to the GPU on the first number, it will limit the performance. And this is the correctly profile for virtualizations. You know, all the BCI slot and GPU will attack and divide for two number correctly. Next is some tip for optimization in the OpenStack. First, you can use the core isolation and host space, and the GPU and CPU affinity for optimizing the number topology for the virtual machine CPU and GPU. And nextly, you can use CPU pinning for isolate the CPU for the virtual machine to dedicate the performance with the GPU instance. Next is about GPU power consumption. It's very important because GPU need power to work. So some of server like HPCs have the power saving mode, and then when we choose this mode, the performance of GPU will be degraded. So when we change to the high performance mode, you can see that the result of the same testing of my eQC application is better than the power saving mode. Next is about some of our problem while working with the GPU with OpenStack. The first, when we create a multi-GPU backthrough instance with the memory higher than 1 TB, and the VM will stack can start in correctly, but when you use the command of NVIDIA SMI command to check the GPU, they will fail. And when we check the DMS log, they will show that we fail to assign the memory to the instance. So why this happen? Because with the OpenStack lower than the version of Caracal, they will limit the physical bits to 42, which means they're not enough memory space for the GPU and the memory. So the solution is you need to manually increase this physical bit to 40, higher than 42 by manual edit the XML versus XML. But it's a very risk way, because when the virtual machine, when you hard reboot virtual machine, on the customization will disappear, and that's a corrupt the virtual machine. So the best way to operate a physical fix in the OpenStack Caracal, that will be have the separate configuration for define the physical bits in the Nova compute. The next is one issue, very rare issue. When you reside in the GPU virtual machine and you have no GPU left on your OpenStack cluster, it will fail. And because with the resize and migrate operation, then it one GPU available to passing the scheduler filter. So this is the bug that I have report to the Nova team. And to work around, we need to manually disable the BC battery filter in Nova scheduler, and then you resize or migrate the instance, and then they re-enable this filter. This is the workaround solution for waiting the official fix from Nova. So this is on for our presentation. Thank you very much for being here.